Transporters and P-class ATPase pumps have two binding sites, one on each side of the transmembrane cavity. Transporters and pumps exist in two conformations. In the relaxed E1 conformation, the high-affinity binding site is open and the low-affinity site is closed. In the E2 conformation, the opposite occurs. The low-affinity binding site opens and the high-affinity closes. To understand the mechanism for transporter translocation, we begin with the simplest case, a uniporter. In the E1 conformation, a substrate is bound by the uniporter's high-affinity binding site. Substrate binding causes a conformational shift to the E2 state. The high-affinity binding site closes while the low-affinity site opens. The substrate is squeezed out of the high-affinity site to the low-affinity site on the other side of the cavity. Binding by the low-affinity site is too weak to hold the substrate, so it is released on the opposite side of the membrane. Once the substrate is released, the transporter returns to the E1 conformation. The process repeats, shuttling one substrate at a time across the membrane. Note, the sites can be on either side of a transport protein. The orientation of the binding sites determines the direction of translocation. For instance, if the high-affinity site were on the extracellular side, then the substrate would diffuse into the cell. Symporters function like uniporters, except that they have two cavities, with the high and low affinity sites on the same side of the membrane. Antiporters also have two cavities, but their high and low affinity sites are on opposite sides of the membrane. P-class ATPases function like transporters, except that they have an ATPase domain that hydrolyzes ATP to drive substrates against their concentration gradients or electric potential. As with transporters, a pump begins in the E1 conformation, with a substrate binding the high-affinity site. Substrate binding activates the ATPase. Energy from ATP hydrolysis drives the conformational transition to the E2 state, closing the high-affinity site and opening the low-affinity site. The substrate is then released from the low-affinity site on the opposite side of the membrane. Thus, energy from ATP hydrolysis forces the substrate across the membrane against its concentration gradient or electric potential. This has been an excerpt from the Biology from Molecules to Embryos educational program. Check it out.